Our first speaker today is Alex Coulomb, who is the co-founder and creative director of Agile Lens. Really excited to have Alex here to give a talk. He's an expert in AR and VR, and he's going to use a real-life example of some work that he's been doing on a single project over a number of years. And you'll be able to see how AR and VR technology has developed from what it was at the start to what it was at the end. And you'll be able to see the amazing differences that we can find in today's technology with photorealism.
Hi everyone, thanks so much for joining us. I'm Alex Coulomb and I am so excited to be here at the NXTBLD Virtual Conference. I've been looking forward to this event for a while. Not so much the virtual version, I did want to go to London, but this particular talk is one that I have tried to give twice so far in the year 2020. First at a theater conference, and then at a real-time, emerging tech conference. And so this is kind of the premiere of it. And I've been excited about this particular talk for a while. I've been hoping for about the past 5 years that something like this would get to come together. So here we are, the very first project that I've been able to be a part of that was able to use virtual reality from conception to completion. And that's just very exciting to me. So moving right along, because we don't have a ton of time. First, who's Agile Lens? Who am I? Where am I? Who am I from? Where am I from? New York City is one of those answers. And I never quite know how to define Agile Lens, so I think that it's usually most useful to just talk about our recent projects. So right now, this is kind of, since September, we've been consulting with the Perlman Performing Arts Center at the World Trade Center. This is a theater that I have known about the existence of since I was in high school. I wrote a paper about it when the whole plan for Ground Zero was laid out. And right now my company gets to help them figure out how to integrate various emerging tech, virtual production, VR, AR, holograms, projection, whatever, into theater, which is very exciting. So that's kind of consulting. On content creation, we helped develop a platform for the Infinite Playa, which is one of the Burning Man official multiverses. And that works in VR, and that is going to be kind of a template for future VR massive multi-user experiences, all in Unreal Engine. We also worked in Mozilla Hubs recently. This was a couple weeks ago. We did a live performance of a little theater piece called Jettison, where we had the actors both composited together inside a browser, and then we also had them perform as their avatars kind of at the halfway mark in the show. So a little virtual theater and great little show, and it all ran in a browser, 2D or VR. It all worked together, super accessible. Also a big fan of teaching and education and, giving talks like this one. So since last year or this year, 2020 spring semester seems like a billion years ago, but spring semester of 2020, I was teaching Unity at the Syracuse School of Architecture. And then this semester, I'm at the NYU Tisch School for the Arts teaching drama and game design students how to give good live performance in VR, along with some other Agile Lens collaborators. And that's been really excellent. And then I also recently became an Unreal Engine authorized instructor, which is very exciting. And I just like to bring it up whenever I can because it feels great. And then I can't really talk about this right now, but I do bring it up because I want you to keep an eye on my socials. Check out iRuse at Twitter, because there will be more information about this soon. But I'm working on what I believe is the world's first virtual volumetric keynote speech. And that involved a virtual theater and using some very cool volumetric capture technology. So keep an eye out for that. And then lastly, I bring up David Geffen Hall at Lincoln Center, because even though I've gotten to work on quite a few virtual theaters over the years, this is the one that I hope will become a sequel to the talk I'm about to give about the Brockman Hall for Opera, because we've taken a lot of the lessons from Brockman and brought those and enhanced those and yes-anded those, to use an improv term, for David Geffen Hall. So just look forward to that. Martin, invite me back next year, and maybe I can give that sequel talk actually in London. And so where did Agile Lens come from, and how did we get to this point where we could actually use virtual reality across the entire design of a theater? Well, Agile Lens grew out of Fisher Dax Associates, which designs theaters all over the world. They're a theater consultant. And I was working there in 2012 and 2013 when the Oculus Rift came out, and that was really kind of an expansion of the work that Fisher Dax had already been doing since the 80s for testing sightlines. So when I got there, we started to do these, kind of simple renders to just say, hey, here's 5 different seating options. Which one do you like best? And we found that with these, fairly straightforward 2D images where it's like the same seat in 4 different ways, but then we might get into a discussion with the client where they say, I don't know, that head there, that looks really close. And you say, no, it's 2 feet away, like that feels pretty standard. Or they might say like, oh, the stage looks so far away. And you say, oh, it's 45 feet, like not that far. Trust me, it's like a normal theater, whatever. And it's just very hard to convey that information in 2D. So in 2013, we got the Oculus Rift DK1, quickly followed up with the DK2, and the ability to do those same kinds of seating options, but now where someone actually has a sense of space and presence and what it's like to lean just a few inches and how that affects your view. That was an incredibly powerful tool. It was a game changer. And immediately we started to find other uses for this, not just sight lines, but cycling through different design options. And so the very first project we finished this for was the Sichu Center for Chinese Opera in West Kowloon, China. And it was great. It was a very curvy space, a lot of Rhino modeling, trying to make its way into Revit, and being able to very quickly compare option A, B, C, D for especially those railings and those curves was wonderful. And then we decided to form Agile Lens as a separate company to be able to focus on building these kinds of experiences. And then over the next few years, got to work on a very wide number of experiences where virtual reality had some tools for the Statue of Liberty Museum on Liberty Island with FX Collaborative. That was primarily a design review tool, which I feel like is one of the more common uses for VR. Seattle Rep was a great quick little Unreal Engine study where I feel like we really captured the essence of what the final space would feel like, and we're able to look at different options for that wooden screen on the wall. And we're able to make it very accessible to have it like run on a phone. And then, we had other projects with various lessons, too much photorealism too quickly, being able to grab a section box around a piece of a Revit model and getting really useful information really fast for an internal design team. But what we really wanted was a project where VR could be part of the design process through the entire project lifecycle. And that finally came in 2015 with the Rice University Music and Performing Arts Center, known then as RUMPAC, now known as the Brockman Hall for Opera. And so we're going to go through some lessons, what we learned over the course of this process. Lesson 1, as I just briefly alluded to, is that to feel immersed in a project, it doesn't need to be photorealistic. So right from the beginning, when we were just playing in SketchUp for the different designs for this hall, no textures, no lighting, nothing that was going to distract from purely the spatial experience. We were testing sightlines here, putting different things on stage, but really it was just like, how does it feel to be in this version of the design with this on stage, or the seats in this configuration versus others? So you'll see there's a blue scheme and a green scheme. And it was an incredibly useful study at this stage to just talk about that expansion and contraction of the different versions and test it out from different spots in the hall. And from there, as the project made its way into Revit, we started to develop it further. We got a hold of some Vive trackers. I had some fun early experiments with those, doing things like battling a ceiling fan, but then bringing it into the practical world, we found that it was really useful when we could start to not rely on VR controllers so much and actually deal with real world objects. So here, we just took an Eames chair that was in our office, got a 3D model of it, and then tracked it in such a way so that while we were in the theater, we could actually adjust the locations of different seats, and then that would actually make its way back into Revit, into the actual design, so we could really fine-tune exactly where different locations would be. We could discover new seating locations. We could check out, the distance from a seat to a rail, and again, talk about what that experience felt like. And lesson 3 became that it is useful to cycle design options for everything in the project, everything you can imagine. So we found that we were cycling everything from places to put the aisles, to places to put the railings, to the columns, to how the seating could be configured, to where we might want to place lighting locations, to what would be on stage. And we could cycle through all of these options in the same VR experience. And not only that, we could also cycle through the different versions of the project. You see the green there, that's the old SketchUp model, so that if at any point we're wondering, like, man, I feel like we lost some essence of the design. Like you click a button and now you're back in where the project design was at a more conceptual level. And that became really useful to make sure that there was some spirit that carried through the entire design process. Lesson 4 became, it is so important to actively make design decisions from within VR, and not so much in a design review capacity where you're just looking at the model and then changing to some different options, but actually like grabbing a ceiling and moving it up and down and saying, down, 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 stop, that's good, leave it there. That has a lot of power to it. But it can also be great for something as simple as a sketch. You know, we've all seen napkin sketches, and this idea that you have this party, this essence of a project distilled into a sketch. But if you do that in a virtual reality capacity, then you can actually add some scale and dimension and human experience to a sketch. You're not prescribing wall thickness or where light is coming from, but you can have a sense of compression and release, for example, as you move through a project. And that can become kind of almost like trace paper, like an underlay, as you start to lay out other design decisions. And you can start to play with lighting, massing, simple concepts that build upon each other from within VR. So this is just the standard Unreal Engine VR editor. Nothing too special here, but it's an incredibly powerful workflow as designers. We also started to play with set designers. This was actually a little thing we did at a conference where we let set designers actually take the stage for Brockman Hall and play with just sketching on top of it. And then they could drop their designs into the actual theater at its current state and jump around to different seats and see, you know, how does that feel? And then for the railings, we really went above and beyond by making it so that there was an algorithm that started to dictate how the railing was designed. And we actually allowed the architect, Alan Greenberg Architects, to like sit down and just grab parts of the railing, these 3 parts to it. And then within certain code constraints, they could kind of push and pull it and say, you know, what feels most ergonomically correct. And then they could say, okay, that feels good. And then that, again, could make its way back into the actual design. Very powerful. Lesson 5 is that photorealism does have its place. As the design gets further along, it is incredibly useful to say, like, okay, but really, what's the project going to look like? And so for us, you know, we were in Unity for the first couple phases of this project, and that was great. But then when we started to get to a point where we're playing with more color and light, we needed something that felt a little more photorealistic. So at that point, we actually brought the project over into Unreal Engine. And here we are again in the VR editor, nothing special here. And all we're doing is playing with color, you know. And when you get that level of photorealism that Unreal kind of has out of the box, you really start to feel how color and light change the sensation of being in a space. Not to mention that it's incredibly easy to scale up, scale down. With a click of a button from the VR editor, you can go back to human scale, but you can also get in this kind of dollhouse mode, similar to Tilt Brush if you've played in there. And it's just an incredibly powerful way to look and evaluate the current state of a design. So here we kind of set a few presets of colors and then could, you know, have someone put on the headset and just really quickly cycle through them. This isn't like something that's scripted and coded. This just became the undo and the redo button. And then, of course, we populated it with people and had a lot of the same functionality that we had in the Unity experience, such as the ability to jump to any seat and then seeing what that view is like. And having the room actually full of animated people, of course, had an incredible immersion multiplier to really make you feel like you are in what is going to be the final space. And taking that further, just like we played with sketching set designs via Tilt Brush, we also started to put real designs in there and some volumetric captures of, you know, simple performers just to have a sense of activity and what it's like in the space. We also played with changing the capacity. And I'll tell you, it's very sad to be standing on the stage and pretending to perform and only having 25% capacity. On the other hand, it feels very cool to be there on the stage and have a virtual standing ovation. I've had a few, let's say, guest stars come to the office in New York City, and they always get a kick out of being on the stage. And I press a little button that makes everyone cheer and clap for them. I'll do that for you too. If anyone wants to come to my office in New York City, you will get a standing ovation. Lesson 6 is once you have a really robust VR model, especially when you're at that photoreal level, it's a great place to actually generate 2D media. So a lot of times we get asked like, well, you know, do you really need to make a VR model? Can you just make us some renders or some animations? And the answer, of course, is yes. But like there's a million reasons why we'd always prefer to actually go as far as VR, because you're actually going to understand what it will be like for humans to occupy the space at some point in a way that no other medium quite conveys. But then also once you're there, then you can start to generate images and animations and all those things very quickly, because it is a real-time model running at 90 frames per second. So a pretty good-looking animation can be output in real time, versus if you were doing all that from scratch, you'd be figuring out what to texture and what to light, and there'd be much more of a process to work through all that, versus in VR, again, pretty much real time. As an example of this, for the Yale Schwartzman Center, this was actually a fun little study that Unreal Engine did from our office. So thank you, Sean Hendricks, for this. You can look up the case study if you want. But for Yale Schwartzman Center, we did this kind of study of moving through the space and actually set up all the camera paths using Unreal Engine Sequencer. So then going back over to Rice, there were tons of different ways we could output things, like literally just a high-res shot that's like a command line code in Unreal Engine is great. We could get things out of NVIDIA Ansel. We actually even installed the V-Ray plugin, and we're able to get some great renders out of that. And then, at that point, you can share the 2D content, which has certain benefits over VR. It's more framed, and it's much easier to share across the world, because then we could start to mock up things like some of those different color palettes we were looking at in VR very quickly. So here was a red scheme and a blue scheme, and then a lighter blue scheme and an orange scheme, and the top center one was where this ultimately went over the course of about a year. And we were able to, again, just mock all this up in VR, and then once we'd made a decision, then boom, output all of these from Unreal Engine, and very useful for showing clients over email or anyone who doesn't want to put on a VR headset. You're always going to have people who, for one reason or another, aren't going to put on another headset. So having alternative experiences, like what I was showing with Seattle Rep, like on your phone, like a web VR experience, is great. Lesson 7, VR is going to save everyone involved with the project time, money, headaches, change orders. I don't know how to emphasize this enough. There might be a little bit more cost up front with like getting these models robust, but let's just say significant reduction in all those things. I felt it. I felt it on this project. There were fewer meetings. The meetings went faster. Everyone was happier with where the design was going. More people were smiling. All good news. And I like to show this slide. This is something that's been put together by Fisher Dax Associates. Great moments in contracting, where 2D representations of design and architecture, such as a revision bubble or a call out, sometimes get misinterpreted. So the more time you can get everyone involved with the project to spend time inside a VR headset, or even just a real-time version of a model or something that feels fairly photorealistic, then the fewer of these kinds of headaches that you're going to run into when the project is actually being built. So here we go. This is a little drone footage of the actual construction site. And it's amazing to see something like this and be like, oh my God, no surprises. This is exactly what I thought it would look like, because we spent so much time inside VR. Not just me, everyone on the project. Here's a nice little Giphy GIF, just kind of sliding back and forth between our render coming out of Unreal Engine and V-Ray over to the actual construction site. And then here's a render that, I think is a little bit overexposed, but we could work on this a little bit more. Just kidding, that's the final project. This image, I think, just came out like a few days ago, and it's like, oh, hey, great. Yeah, in some ways, I'd say the render looks a little better than the final project, but there's just like a really nice level of verisimilitude. So ultimately, the goal here is pretty simple. We are trying to cut down on the design review element of using VR, where you pop your head in the VR headset, go back to a computer, make some changes in VR, computer, back and forth, and then ultimately coming out the building and having a little bit more of this active design, this inside-out experience of you start on your computer, you do all the precise things there, you go over to VR, and then some sense of what you change or modify in VR makes its way into the final design. And I'll also mention that sometimes it can be really excellent to use these models for virtual architecture. That's a talk in itself, but then that involves a little bit more of a process of starting on a computer, maybe massing some stuff out, maybe starting in VR, and then ultimately just outputting the thing to VR. Maybe this is a design or an experience that has very clear functionality. Let's take Infinite Playa, for example, where you're going to have a ton of people going into the actual space, and it's never going to be built in the real world, but it still needs to serve the same functions as real world architecture. So there's some real opportunities coming up, I think, for anyone with a great design aesthetic to work on these kinds of things. And anyway, on that note, though, I do want to mention that this project, you can visit it in Houston, Texas, but also we're partnered with Guru right now. And also Guru is partnered with NVIDIA and Unreal Engine. So we have the two other speakers tied into this. But you can visit the Brockman Hall for Opera in Guru's platform starting very soon. So that will actually be like a multi-user space. You could give a talk there. You could have a meeting of the minds there. Check out Guru in your own time. They're a very cool company. But that's kind of where we're wrapping up. So there's the lessons, all 7 of them. If you have any questions or you want me to elaborate on any of them, excited for the Q&A, or just reach out to me. I am at iBrews on Twitter and Facebook, and thank you very much.
Our next presenter is Andrew Rink. Andrew leads the global marketing strategy for the AEC industry at NVIDIA. Andrew joins us today to share an innovative development at NVIDIA that will help AEC firms improve collaboration, accurately simulate virtual buildings, and help keep project teams on track.
Okay, hello. This is Andrew Rink from NVIDIA, broadcasting from the NXTBLD 2020 Virtual Conference. Thanks for taking a moment to join this presentation on overcoming collaboration challenges in architectural design. I wanted to kick things off with a look at a few significant trends that the AEC industry is seeing when it comes to building and infrastructure design. Of course, as we all know, there are a lot of moving parts with AEC projects where typically a wide variety of team members and their clients work together, grappling with numerous processes. Geographic dispersion of contributors from a broad range of disciplines is commonplace for global AEC firms while collaborating on designing buildings. That expertise is often located remotely. For example, a lighting expert in New York City, an acoustics consultant in London, with perhaps the owner-developer residing in Shanghai. So companies are finding talent all over the world, and they have to deal with the complexity of managing these widely distributed project teams, all working together under tight deadlines. And not only are milestones, deadlines, and margins getting tighter, but building projects are becoming more complex, and the requirement to deliver those projects more quickly and more cost effectively keeps growing. Another trend that has gathered pace in the past couple of years is companies adopting leading-edge technologies that help them optimize building designs and lower construction costs by reducing rework. This trend is being partly propelled by a need for better design visualization of building interiors and exteriors, which drives faster, more confident decision-making. So more firms have embraced virtual reality and photoreal rendering and using those technologies early in the design process. In addition, we're increasingly seeing a desire by architecture firms to simulate their designs before construction begins. By accurately simulating how the building will appear and function in real life, for example, how airflows behave inside and around structures, or how sunlight reflects off glass surfaces at various times of the year, that level of accurate simulation is proving to be extremely helpful to teams for identifying flaws and optimizing designs. As a result of these industry trends, the obstacles faced by AEC firms become a bit more challenging. Efficient collaboration has typically been problematic, but it's getting even more so these days. Those geographically dispersed teams can have difficulty exchanging ideas and information, and that can result in duplication of work or delays with agreeing on decisions. It's also difficult to effectively communicate design intent when a project team is made up of so many different contributors with varied areas of expertise. And of course, you throw in the client into that mix, which naturally is a necessary complication. Often clients and even project members have trouble visualizing how building interiors and exteriors will appear in real life, and many software tools lack high-quality visual outputs. So extensive discussions are needed before making decisions with confidence. The result is lengthy design review cycles, which ultimately leads to delays, and many of us have had to work through those. A third area of challenge is optimizing IT infrastructure. Companies need to maintain high productivity with a flexible global workforce. That means onboarding and offboarding project team members quickly and cost effectively. Those employees require quick access to secure datasets from anywhere at any time on any device. Then there's the lack of interoperability between design and visualization software tools, which is a pretty significant cause of wasted time with data translation, not to mention errors, but also often requires time-consuming decimation of the models in order to visualize them effectively. So considering these industry trends and challenges, NVIDIA has been working hard on developing technologies that can help AEC design teams improve their building design workflows. Earlier this year, we introduced NVIDIA Omniverse, which is a computer graphics and simulation platform that enables AEC firms to collaborate in real time on a photoreal digital twin to help teams maximize productivity. Omniverse was built by NVIDIA as an internal tool to simulate virtual worlds for our development of autonomous vehicles, robotics, and so on. We recognized the benefits the platform delivered for our teams, so we initially offered if you like, an alpha version to a limited set of customers with whom we work closely to play with it and find out if it would be helpful for them. Several of those customers are leading architecture firms, so we built on the Omniverse platform the AEC experience, a set of tools and extensions focused on concept design, visualization, and design review. So let me dive into some detail about Omniverse. As you may know, NVIDIA has a history of developing SDKs, software development kits, to facilitate use of GPU-accelerated technologies. You see a few of them here at the top. These are aimed at interactive ray tracing or for accurately simulating wind flow and rigid and soft body dynamics, or VR works to push the boundaries of high-fidelity virtual reality. Traditionally, when new technology gets introduced, it could take a year or longer for ISVs, for software vendors to implement these in their products. Obviously, they have to commit resources and schedule the work, test it, and then release it to their customers. What if we were able to bring out a new technology and that very same day applications could take advantage of it? That's one of the core advantages of the Omniverse platform. Based on Pixar's Universal Scene Description Framework, or USD framework, and NVIDIA RTX, built on a unified architecture which is shared by all applications in real time. So when we enable a new technology, all the products using Omniverse have access to it immediately. You keep hearing me refer to Omniverse as a platform. Now let's look at the various components. Omniverse Nucleus is the file server that hosts and synchronizes the shared USD files. Omniverse Connect is integrated into software applications such as Autodesk Revit, McNeil Rhino, and Trimble SketchUp to connect and collaborate on the same scene file hosted by Nucleus. This live connection enables users to quickly iterate on a project together, while Omniverse View is a standalone app that provides a view of the USD scene augmented with real-time RTX rendering. It offers basic scene and material editing capabilities, as well as industry-specific features like light or sun studies. Then there's a simulation module included for experimentation and customization and to accurately simulate the virtual world. And RTX Render is available for those who need the highest possible fidelity when visualizing fully ray-traced, physically accurate building models in real time. Here's a brief video that showcases how the Omniverse AEC experience works and some of the features and tools. Hopefully that video helped you visualize the potential of how Omniverse could help overcome collaboration challenges for you and your teams. We saw how project teams are unified on a single interactive platform, even when simultaneously working with different software applications, allowing a team to rapidly develop architectural models in real time. And you get seamless updates and changes to further simplify collaboration. We saw the ability to go from design to ray-traced view in one click, so you can see beautiful, physically accurate visuals with minimal effort. When you watch interactive ray tracing of the building model taking place in Omniverse in real time, it's hard to believe it's not a filmed video. You don't have to do any data prep or decimation of the model, which means you avoid wasted time and costly delays in translation and errors between software tools. And teams can speed up the design approval process since decision makers can view that high fidelity model on just about any device from anywhere. We're fortunate at NVIDIA to work closely with a lot of great people at leading firms all over the world. And we're gratified that several of them took the time to evaluate Omniverse and offer feedback and recommendations, which really helped us refine the platform over the past several months. Woods Backett, of course, a global architecture and consulting practice, has team members located all over the planet, so remote collaboration is a big deal for them. You can read their impression here. We were also very pleased to get input on Omniverse from Cohn Peterson Fox. Many of you will be familiar with KPF, who are particularly known for their designs of super tall buildings. For KPF, the ability to get physically correct visualization at the highest fidelity with real-time ray tracing is a huge benefit to their design teams. So we've had plenty of feedback and encouragement from customers helping development of Omniverse, as well as support from our partners in the software space serving the AEC industry. We're at the beginning of developing Omniverse, and the platform will continue to evolve as we add features and functionality in the future. I'm pleased to tell you that we have just announced that the NVIDIA Omniverse Open Beta will be available in the fall. So I invite all of you To try out this early version and evaluate how it helps your collaboration workflows, just type NVIDIA Omniverse into your online search engine to find out how to access it. Well, that wraps up my presentation on overcoming collaboration challenges in architectural design. Be sure to join us for the live Q&A at the end of today's sessions. Thanks for watching.
Good afternoon. I'd like to introduce you to this afternoon's next speaker, Ken Pimentel from Epic Games. He's the AEC Strategic Business Development Manager at the company that we all know produces Unreal. Hi, Ken.
Hey there, Martin.
So first, Epic Games got serious about AEC in 2018. And when AEC Magazine interviewed Mark Petit, the general manager, he spoke about the ambition for Unreal Engine to become a hub for all AEC data throughout the design process and beyond. The idea is that Unreal Engine wouldn't just be for visualization, which is how we probably see it historically, but for engineering data as well, to support both engineering and aesthetic design decision-making. And ultimately, it's seen that Unreal will actually act as an aggregation platform in the AEC space. So to really sort of make this work, obviously, Unreal Engine needs to become integrated into the BIM process and to make really good use of the BIM object data. So how far along have you got to actually delivering on the vision of integrating Unreal into the BIM workflow?
Yeah, in the entirety of it. I mean, it's a little over a year, and what a year it's been since I presented on stage there in London with you. So it's exciting just to see how far we've come. I think a lot of things have come together quickly, and what we want to do is just show you some of this. So the conversations that we have with customers focuses on these kinds of bubbles of capability. And of course, virtual collaboration is a hot thing, and hopefully we'll get a chance to talk more about that. But there's a lot of places that we're seeing Unreal adopted. And if we look at the workflow, it's progressed. We've got a solid lineup of Datasmith support for different tools. And there's really three components here. The first are the things that we do. So for example, we're adding Navisworks support in 426, which is just in previews right now. So people can get to take their Navisworks data and bring it into through Datasmith into Unreal, and into Twinmotion. So we develop a bunch of these. There's a bunch of partners that have built Datasmith export into their products. So Safe Software has their FME product. That's part of their offering. So you can wire up Datasmith generation into that. Esri City Engine, of course, is the first, actually our very first Datasmith supporter. Bentley Synchro Pro, they've given me the okay to announce support for Datasmith.
That's great.
In that coming up. ArchiCAD has produced a Datasmith export mechanism. So, and there's many more coming. This is just ones I can talk about publicly. On the other end, there are partners that are making connections directly into Unreal. So for example, Cesium, that's a GIS tool that brings worlds that are geo-located, geo-specific, geo-referenced worlds into Unreal Engine directly through a streaming process. Esri's ArcGIS Online, the world's foremost GIS tool, is announced they're doing something similar. Their beta just starts in, I think, next week for that. So it lets you connect in real time all the world of GIS with all the world of Unreal. Sin2, people may not have heard of it, but it's a point cloud platform for processing your data. It'll stream into Unreal. Everyone knows Rhino. Rhino Inside for Unreal is a project that's out there that people are playing with to figure out how to put Rhino directly into Unreal. And then some you may or may not be familiar with, but Bureau Happold has built this open source free framework for interchange called BHOM, and they're a big user of Unreal. So that's tied into that. It's all free. And Speckle, we're getting behind Speckle in supporting them. There's already a beta of an Unreal Bridge, and there's more work coming there. So, you know, it's just popping up everywhere, this idea of how do I connect my data, my engineering data, my design data, my GIS data, and bring it into Unreal. One of our initiatives is to combine Datasmith with something in Twinmotion called Direct Link. So Direct Link, it gives you a kind of a real-time connection between, let's say, Revit and Twinmotion. You have this live link that you can hit sync, and it'll push the changes from Revit over to Twinmotion in a non-destructive way. We're going to combine that with Datasmith, and we're in 426 coming out right now in Unreal. You'll see the first results of that, where Revit has this ability to form a live direct link with Unreal Engine. So you could be working in Revit and you say sync, it'll update in Unreal.
And it's only going to exchange the new info.
Yeah.
Refresh the whole model.
Yes. So this is fundamentally moving away from a static workflow, which has its purposes, but to give you also a connected workflow, to allow you to basically connect your tools directly to Twinmotion or Unreal. So the future, if we look at what's coming, imagine if you could have all these different apps, all of your design tools emitting a stream that then goes into Twinmotion or Unreal. And so that's what is coming. That's something we're working on. We see a future where you'll have peer-to-peer streaming, no need for a server. You'll just make these connections and be able to flow your data downstream into Unreal or Twinmotion. So Twinmotion and Unreal will have the same datasmith capabilities. That's something else we're evolving towards, where one is identical to the others essentially in terms of what data sources what data emitters you can connect to, and we're going to share that basically aggregation engine in both
So
products.
let me get this straight. You're not just talking about sending data from one application into Twinmotion or Unreal. You could have multiple. So you could have a building designed in ArchiCAD with GIS data from Esri, and all that is streaming simultaneously into the Unreal or Twinmotion solutions.
That's the promise of it. As long as a partner has developed the Datasmith interface, they can, when we give them the capability, they'll be able to upgrade that to this direct link. So anybody that's producing Datasmith files has this possibility of also enabling this connected workflow. So it's very exciting for us to see that happen.
Wow, that's incredible. All right, okay. So obviously, I think we spoke when COVID hit, and we were talking about how busy you were, even though it was the downtime. It was around that time where every architectural practice had to try and work out how to work remotely with their own teams and clients. And you mentioned collaboration was something that was very hot topic for people to discuss with you, what you can do. Now, I have never played Fortnite because I feel I would be addicted to it, so I have avoided it. But with Fortnite, I know Epic Games has developed a whole load of collaboration technology for people to be in the same environment and work together. So I'm wondering, how's some of that technology working its way into the AEC frameworks of Unreal? Is this something you can tell
Yes.
us?
So we were early on, we had a collaborative template that we made available for free, and it allowed people to basically drop their assets into Unreal Engine and start collaborating. So we've enhanced that, we've improved upon it. So people still have that option, but they also have a whole bunch of other options now. So Thea is just releasing in beta what they call their big room. And this allows anyone to, it's a template approach. So it allows customers to bring their own data into Big Room. It's all blueprint.
Yeah.
So customers can make all the changes. If they don't like how the tool works one way, they can change it to work another way. So it's an exciting, this is kind of the future of collaboration, especially when we have the restrictions that we have on ourselves. There's also the idea of pixel streaming. So how do you get a stakeholder to experience your project when it might require a GPU? Maybe they don't have one, or they don't have a powerful enough one. This is a demonstration of a Unreal Engine application up on a cloud. It's using the GPU on the cloud, and it's just doing a video stream. It'll stream to any device. So you can look at this on a browser. You can interact with it. It's not just for looking, it's for interaction also. So you have all these options that you have with a desktop, but you can deploy it via the cloud.
Wow. Okay.
So we're seeing lots of interest in that. That's why one of the reasons I brought it up is that this is one of the more popular things people are exploring. And then we can announce on today that there's a new thing that we've built. It's called Twinmotion Presenter Cloud. It's in beta, and then the idea is that customers working in Twinmotion will be able to publish to a GPU cloud. They'll get back a URL that then they can share with their stakeholders or collaborators, and that's all they need. That collaborator can be looking at Twinmotion running on their device, whatever it be, mobile, tablet, whatever. It's a video stream using our pixel streaming tech to enable that.
So is it how fast can it stream? Is this something that could power some VR headsets, or you're not really going to?
No, it's more of a desktop experience, interactive desktop experience.
Do you think we'll ever get to the stage where you can get that VR live?
NVIDIA's experimenting with that. They have Cloud XR, so they've launched. That's in beta right now, I believe, and that I've heard good things about it. Where it could have a future where you have a connected capability, and you just put your headset on and you log in, and it's all streamed to you. So that is nearer than you might think.
So one of the hot topics that we're covering all the time is digital twins. Data is the most important part of any digital twin. The actual geometry itself is perhaps secondary. So how is the Unreal platform able to work with complex databases, and how can IoT and other real-time information be fed into the system?
Yeah, I think we're seeing enormous interest around it. We did some of your viewers might have seen the B1M video that was put out. It has roughly 6 million impressions. Basically, the idea is once you have this interactive platform and you have C++ APIs, it's fairly straightforward for a programmer to bring in data from any source. So we've seen an explosion of applications of all different scales. One of the ones, the B1M video covers the work being done at 51 World in China. It's amazing the scale of the projects they're tackling. It's everything from city scale to building scale, and they're exploring like how do you represent data, what kinds of interfaces are important. And they've been doing this for the last 5 years. So they're probably one of the more sophisticated deployers of digital twins where there's, a 3D world makes sense. So like here's all of Shanghai in Unreal. I mean, the capabilities of Unreal to bring in massive data sets like this is just phenomenal. And here they're using pixel streaming to bring that complex experience onto a tablet. So they're showing how it can all come together. So I think expect a lot of exciting, more stories. We're working on an effort to get out a little development template for people that want to start playing with this, that helps them navigate building a digital twin for themselves.
And you're not talking about a digital twin of a building, you're talking about cities scale as well, which is more impressive. Rather than dealing with the small problem, you're dealing with the much bigger one.
I'd say there's more interest at the city scale than the building scale right now. I think the cities are driving a lot of the interest, or the town councils driving a lot of the interest, because they see it as a simple interface into this complex world of their town.
Yeah. Especially countries like Singapore, who have got a very strong digital outlook. Obviously China. We need to start seeing some European countries. I know Helsinki's got a very good one.
No, but the UK, there's initiatives, there's Digitally Built Britain. There's lots of happening here. There are town councils looking at it. We've been approached to be part of teams on them. So it's happening.
It's happening. Great. So last year you acquired Twinmotion and surprised us all. You now have a really sort of impressive end-to-end real-time viz tool of architectural components with obviously the main Unreal Engine. But the one criticism is that Unreal itself is quite a very complex product to master. It can do a lot. So how can you make the technology more accessible to users? And will Twinmotion grow in capability? Will you rely on third parties to build on top of it? Or is there going to be a light version of the Unreal Engine?
So we're talking about different things here. One of it is the, what happened. So a year ago, we acquired Twinmotion, put out a new version of it. And this is a recent, this survey was just finished in the last month. So these results are up on the website. And basically what we see is Unreal and Twinmotion are the tools people are looking at for the future. So that's very encouraging to us, that our investment is getting paid back. So that's hard data of these are people that care about pixels, and they've chosen our tools. These are examples of various customers pushing what's possible in Unreal. I mean, for interiors, look, using NVIDIA's RTX GPUs, you now can have real-time quality at offline, basic real-time performance at offline quality. So there's less and less of a trade-off you have to make to take advantage of the best imagery. And this is transforming processes, because if you're in traditional ArchViz, if you have to produce an animation, you have to book time and lock down a project. You can't keep developing that project up to the very moment you get in front of the stakeholder. So if your competitor can iterate on their project faster than you because they're using real-time technologies, they're going to be able to explore more possibilities than you can based on a slower process. So that's something that's exciting. I think you were also asking about Twinmotion, and let me jump into that a little bit. So, 500,000 registered users at this point, blew away what we kind of were expecting. And the projects that are being produced these are all straight out of Twinmotion. There's no games being played in other post-processing tools. But the point is that, we can handle scale. It isn't limited to small projects. Big projects can be taken on. There's a video of this whole city in Twinmotion in Australia, which we're working on to promote. So Twinmotion boundaries are expanding, but its ease of use needs to be maintained. And where's it going? Well, in 426, Unreal Engine 426, for the first time, you'll be able to start a project in Twinmotion and finish it in Unreal. And this really opens up, the black box. So many tools that firms use to produce visuals are kind of black box. They can't get data out of it. They can put data in, but they can't really get data out of it. And here, for the first time, we really are breaking that open by letting people fully leverage that ease of use, but then take it wherever their imagination takes them in Unreal.
Cool. So we've talked a little bit about desktop rendering, cloud rendering. I mentioned virtual reality on the way, but we haven't really talked about augmented reality. Is there anything that you're working on that space for mixed reality?
Yeah, so for there's a range of ways that you might want to engage a stakeholder. I think there's, we call it XR, that's kind of the term these days. And so just a snapshot, you want to show someone how to visualize, turn their construction site into the finished building, and so AR can give you that window into the future. And what we just added was support for Azure spatial anchors in 426, so you can register your experience to the physical world, and then when you go out on site, it just snaps to that alignment, and now you're seeing the virtual world laid correctly on top of the physical world. So definitely big support for that. There's other things on network shared spaces. There's a lot of work we're doing around XR. People are exploring, what's possible in XR. Here's a mixed reality where you combine 3D printed buildings, white buildings with laser projection, and have it all in real time. So driven by Unreal Engine. So in real time, you can bring in data and have it update and show on this kind of a mixed environment, mixed reality environment. And, for collaboration with people that are not sophisticated with technology, this is kind of the ultimate expression of it, where you can, it's right in front of you and it can transform into telling a different story depending upon the conversation. So we love it when we see people doing innovative things like that.
So last October in London, you showed some sort of preliminary technology, and one of the things you mentioned was point clouds. Obviously, point clouds is actually an important part of digital twins, the as-built versus the design to be built. How's point cloud development come along in Unreal?
I think the best way to talk about it is to show it. We just produced this video of this site. It's what you're seeing is not mesh data. It is 15 billion points at 0.5 millimeter scan density. It's a point cloud, and it's in Unreal Engine. The work they did scanning this site is very hard, very difficult to do. Most scans are not this dense, but if you do the scan properly, you can see what you can get from it. So when Unreal, you get the decision you make is, do I want to show this at ultimate quality, or do I want to set a frame rate and degrade things so that I can move around the point cloud? So you have that control, complete control over quality versus frame rate, and you can combine that with CAD data to get whatever kind of experience that you're looking for.
Do you actually turn point clouds into meshes, or is that?
No, well, we do, we don't. We do allow you to produce a collision mesh from the point cloud using our tools. That gives you the ability to walk around in a point cloud and not fall through the floor if you wanted collisions to experience the building like you were walking around it. So right now, it's been mostly a focus on handling the massive data sets and figuring out the best ways to present them. So a lot of tweaks to the visual algorithms we're using to produce those kind of imagery.
That's cool. So before we leave, one last question, which I'd like to sort of go to a bit of depth. So we've all heard of Epic mega grants. Loads of companies seem to be getting them. So kind of interested in Epic's approach to software development with partners and mega grants, and would like to know a little bit more about what you've funded and what they'll do for Unreal Engine and its customers.
Yes, so the Mega Grants program has been very successful. We've seen, I would say, in the AEC space itself, there's probably 20 Mega Grants working their way through. There are things like Tritify in Finland that has a BIM collaboration tool. They've just announced last week they built their Unreal Engine integration. It's funded the work with the Synchro Pro. It is building bridges in all sorts of places, so that in another 6 months, I would guess, we're going to be able to show such a connected workflow to tools that help our users across the architecture, engineering, and construction space. So it's not just about architecture, it's also very much about engineering, very much about construction. And those mega grants will help show the way to the future for people interested in applying real-time technology. And we encourage everyone to go make a proposal for AEC. So this is not limited in any way. If you have a really good idea, we're looking for innovation. We're also looking for social benefits. So if you think you have a great idea, please pursue that.
What holes do you think you currently have? So it'd be helpful if you could give an idea of which areas you're specifically interested in at the moment that you don't really have that many developers working with you on.
I think if I give people guidance around mega grants, I think the guidance I'd give them is that try to coordinate with us, the Epic AEC team, so get in touch with us so that we can help you frame out. We're aware of what mega grants are coming through, and there's probably no reason for two of the same thing. So we're trying to help people get their mega grants. So we're very active in that. We just did one for UCL and Foster and Partner. It's for exploring the disadvantage, what the experience is of design. So put somebody who has, let's say, some sight disability, put them using VR, put the architect into that so that they experience design through the eyes of someone that has limitations.
Okay.
So that's a great example of where, it's going to be a benefit for everyone. It's going to be open source. It's going to be something people can build on top of.
Well, thanks for talking this afternoon, Ken. And I look forward to, I think you've got an event soon, haven't you, coming up?
I've lost track of the events.
I think there's an event in October. I'll find out. Anyway, yes. Thank you very much.
No, thank you very much, Martin. It's a pleasure always to talk to your people. Your audience is always on top of things, looking for pushing into the future. We had many great conversations coming out of NXTBLD last year, and we'll certainly be there in the future.
Next year, yes. Cheers.
Cheers.
Hello, and welcome to day 5 of NXTBLD Virtual. We've had quite a show over the last 5 days, and today was the time to have a look at real-time Viz and VR. We've had quite a diverse range of presentations today, and just really blew me away. There's a load of topics in there which I think are really hot and very newsworthy. And I'd like to thank Ken, Andrew, and Alex for putting the effort in and time to get us their presentations. Ken to put up with me mispronouncing his surname. And Alex for doing a fantastic job on probably what I'm going to be telling people is that if you're having trouble validating or getting your bosses to buy into why you should have some VR kit in your design process, those 20 minutes tell you exactly why you should have VR from the conceptual all the way through to the end. And VR is actually part of the design process. It's not something that you shove out the end to impress a client. It's something that actually helps you make decisions, design decisions. And Alex, that was brilliant. That was 20 minutes of a lot of sales of headsets for most architecture firms, I think. So, and obviously NVIDIA graphics cards and Unreal Engine. We're going to kick off with some simple questions to start with. If you've got a question, I think there's a Q&A box somewhere in there. You can type it in there and someone's going to add it to my list of many questions. And I've got questions from the session before where we ran the video. So we are a little bit time limited today, so I'm going to press people to be a little bit short, maybe with their answers, to try and get through everything we've got. Okay, let's start with Alex. So I'm just saying, while it's obvious that VR provides a benefit to design, what are the reasons that the architectural firms haven't necessarily grabbed onto this? Is it all the data wrangling, or is it the ease of use and understanding the software?
Ooh, I have a diplomatic answer and I have kind of a real talk answer. And both are true, but we'll start with the diplomatic one, which is simply that it's a new workflow. And a lot of times when I was trying to evangelize this back in 2013, 2014, the general response was like, oh, we just switched from CAD to BIM, like, don't make us learn something new. And trying to get people to understand that it's not a new workflow so much as it's an extension of their existing workflow. And all the skills that they already have, do make their way into this world. That was a tough hurdle to get over. And I'll say, here's the real thing. There are a lot of architects out there that really enjoy the mystique of everyone not knowing what the design is going to look like until it's too late to change it. And what that ends up doing is if you're in VR, especially early on, it gives the client and everyone who's involved in the design team more chances to point out disagreements and say like, oh, we don't think that's a good idea. Can we change that? And if that mystique can be maintained by the architect, they can get away with more. And anyone who has architectural training, they often don't necessarily need VR as much as everyone else because they can see what these spaces will look like in their mind. And so, yeah, it's a little bit, it reminds me of ancient times, of course, when the only people who could read the Bible were priests. And I think that happens sometimes in architecture. And VR really starts to democratize the design process. So we're still getting over some of those hurdles.
Yeah, actually, if I could add a point, Martin, sorry, it's Andrew. The other thing I think about too is there's a lot of companies that are, from a practical perspective, a lot of companies are on a workstation refresh cycle, a fixed cycle where they, release their equipment and, after 3 years they get the new one. And so if they're, a year or two into that and they don't have a VR-ready GPU, they don't have a system that's powerful enough to do a proper VR experience, they're waiting, right? And, I think a lot of us on this panel would encourage companies, let's speed it up now because you're actually missing out on a big productivity gain by not embracing this technology right away.
How about you, Ken?
Yeah, no, we're seeing one of the trends is people wanting to put everything, the experience on a Quest and just ship it off to the stakeholder. And then stakeholder just puts it on and is there. So we're looking at ways people are trying to distribute the experience. Pixel streaming is another thing, running on NVIDIA hardware in the cloud. We've got lots of activity around that.
So I'm going to ask a question from Jonathan Ingram. He's the father of BIM. He wrote Sonata, Refresh, then got sold to PTC, and then we all saw Revit. Alex, do your designers try using VR, using it for designing for days or hours at a time? And what's the longest that you can stay submerged?
Oh, that's a really interesting discussion point right now. The longest that I've ever been in VR continuously was about 8 hours during a multi-user work session. One thing that my talk today didn't have a lot of was people in the VR experience at the same time. And that's one of the things that has changed a lot in our workflow over the past few years. So if you are playing off of someone else and you're both in VR together, I find that that helps keep the session going. But I'd also say I have pretty strong VR sea legs. There's a very talented VR artist named Danny Bittman who would regularly do 12-hour sessions drawing in VR, and he actually did need to get corrective lenses. So he's one of the first major VR figures I've seen who actually needed to honestly take a step back from it. Was there another part to that question? Sorry.
Well, it was just, it was how long have you stayed in it, and saying, do your designers tire from being inside VR designing for hours?
Yes, and I'd say a lot of times most of the people who I'm working with can work more on the front or the back of the design experience, so not necessarily in VR as much. And I might be focusing much more on everything that is happening in VR, so I'm kind of spearheading that. But it's also like anything else; it's a skill that you learn and develop and build more tolerance for. So anyone who's afraid of it, you just got to practice more.
Well, yeah. And if we go to the other end of the scale, well, VR in its way has got a bit of a barrier of entry because some people just refuse to put the headsets on, or don't want to wear them, or feel seasick, or just don't want to do it. Don't want to be seen by it. So that's a problem. So do you think AR is going to be the actual thing that makes VR and XR an immersive sizzle? Is that people don't have to look and wear such a lot of hardware on their head?
Yeah, well, but AR, of course, often can involve hardware like HoloLens and Magic Leap and devices like that. And on that front, I think the field of view really needs to get bigger, and maybe Apple has some solution for that in their pocket over the next couple of years. And phones are great at that AR level, and the new announcements for iPhone yesterday with a LiDAR scanner and all that starts to add a lot of capability to what you can do with the devices everyone already has, but it does lack that level of scale, which is why personally I will always prefer something that is head mounted and gives you a different view in your left and right eye and allows for some level of depth perception. Because what I want to be able to do is go to a construction site. I mentioned we're doing stuff at the Perlman Center right now, which is under construction. I want to go to the Perlman Center, have a headset on, and have a perfect view of all the systems that are being built today that are going to be built in 6 months, and be able to do meaningful, let's say, adjustments or whatever can be done with that information. And AR isn't quite there yet, but I think once it does get there, we're going to be in a very good place.
It seems to me that each one of those. So I'm always jumping over you, Marta. Sorry. I feel like each of those technologies is excellent for different use cases, right? The overlaying of the schematics and the sort of things that Alex was just describing is one thing, but the actual photorealistic immersion where we're heading into with these high resolution HMDs, it's a different sort of workflow, really.
Yeah, but for AR, I see that especially on the production side, the tablets are already making inroads there because, first of all, the headsets just are not ready for that. And the tablets are. So you can bring up the tablet, you can get the AR experience and interact with it. And they're already on site with the tablets. So we're seeing a lot of interest either in pixel streaming. We have one partner, BIMSync, who is porting their tech over to Unreal just for the single purpose of getting on the construction site with a tablet or a phone.
Yeah. Well, what's happening with Leap? Is Magic Leap going to survive?
Only with something much better than what they have. I think we can say that.
Alex,
we're exposed to their what they're doing, so we're aware of what's possible, but I think it's yet to be seen whether or not what they can bring to market.
Okay, Kevin Quigley has asked, what are the challenges going from VR back to VR? if you make a rapid design iteration in VR, what's the best workflow to get these edits back into CAD?
So can I just, one of our customers, Formitas in Germany, they're a BIM consulting firm. What they've done is they've connected Unreal Engine to BIM Collab, which is one of the industry's tools for keeping track of changes. So while you're in VR, you can find an issue, you can bring up a UI, you can log the issue, assign it, etc., and submit it to the Collab server. So they're going to make that code free for everyone. So I'm working with them on that, and in the next 3 months, we hope to have it available to everyone.
Wow, that's cool.
Yep.
So I've got one for Andrew about Omniverse. So will Omniverse be a subscription service? So what would I do? Would I design something in Rhino and push it to Omniverse for web-based collaboration with clients and contractors?
I think I mostly got the beginning of that, and it sounded like it was a pricing question.
Yeah. Will Omniverse be a subscription service?
Yeah, so what we have announced so far is the open beta is coming up at the end of, well, in the fall, so probably in a month's time or so, and that will be free of charge. So there's there's no, for the open beta, there's no charge. It's free.
But there will that'll come, and then it'll be a cost, I guess.
Yeah, we haven't made any announcements about whether there's going to be fees involved or not.
Another one from Jonathan Ingram again. Can you say a little more about your connection to Unreal, the types of data that are being passed backwards and forwards in particular? That's to Andrew.
Well, so obviously we've been working closely with Unreal. They're doing a terrific job connecting with Omniverse. I mean, I think the main part of that question is about the file format, and so it's the universal scene description, the USD format. That's the common format that's being used within Omniverse to exchange all the files.
Okay, I know that Alex is going to have to leave us in 15 minutes, so I'm going to try and get through the questions to him before he pops off. Can you tell us more about how you do the VR to Revit link?
Yeah, so that it has a few different pipelines, some of which are more complicated than others. The simplest version is that, say we're sketching in Tilt Brush, that can be exported as an FBX or a DWG. If we are in Unreal Engine, a lot of people don't know, you can actually get data out of Unreal Engine. You can export to FBX. And then last I checked, Revit still doesn't import FBX, it does export it. So often what we'll end up doing at the simplest level is converting all of that to a DWG or a SketchUp file, which Revit can take. And then we treat it kind of as an underlay, especially if there's something like sketchy that was mocked up in something like Tilt Brush, then we kind of say, okay, that's kind of the gestural idea. We want like a spiral staircase here, and we want a big window here. And then just the same way you might scan something that you did with trace paper and put that inside Revit, instead we're doing that with 3D data, a 3D sketch, and then using that as, Revit allows for the much more precise code compliant version. Then we've also played with some more robust, let's say, scripting, and that's I guess you could say one of our proprietary services. So it's a little bit more of a real-time two-way road between Revit and Unreal. So maybe someday we'll be able to like license that out or something, but that's been fun to explore.
How did
so Alex,
So
I just want to say that Alex there's something new that we've been working with Speckle. It's an open source platform for moving data around, design data. And they have a beta of Unreal supported. And that, I think it might be unidirectional right now, but they're working on a bidirectional streaming capability of that. So that's something to be aware of.
Yeah, awesome.
I'm coming across a lot of firms that want to get into VR, but they told me that buying the headsets they're put off by the fact that they're updated every year and there's a new version. So as soon as they buy it, by the time they're used to using it, the stuff they've got is out of date. So what's the right way for architectural practices to look at this investment?
I think it's a lot like smartphones. You know, you reach a point in the early days, each release was a huge, you know, jump in performance and capabilities. But at this point, you know, are you still buying a new phone every year? I know I'm not. I wait like 3 years or something between my updates. And I think it's the same with VR. There was a lot of dramatic changes from generation to generation, and we're still in those early days. But there's no question it's going to settle out. And the ones we have this year are all reaching the screen door effect, pretty much gone. Now that's a big improvement right there. And they're all trying to expand on field of view, brightness, comfort, all of those things. And I think we're past the early, you better be an explorer, into these are practical. These can be used to solve real world problems. At least that's my take on it.
And I'll mention that I feel like things are leveling out. Like with the Quest 2, which just came out, I'll just keep holding it up as though I'm being sponsored by Oculus, even though, they're a very anti-competitive company and there's some issues there. But for $300, you get a really robust headset that can work totally wirelessly, totally standalone, doesn't require a computer, or you can use a USB cable and plug it in to a very high-powered machine. Additionally, you can use the Wi-Fi connection, and whether it's NVIDIA Cloud XR, or even there's a $15 app called VR Desktop that allows you to actually remotely go into other computers and utilize that hardware capability. So I'm doing that all the time right now. The computer at my office in New York City is much more powerful than what I have here at home, and you can do a lot with a $300 standalone VR headset now. And I guarantee you, by the way, that hardware costs a lot more than $300 to make. Facebook is definitely trying to, lead the market, and I'm sure they're selling them under cost.
Yeah, I agree with what Ken and Alex are saying. But, probably the one perspective I would add is that I feel that to a large extent it's inevitable. It's the progress of technology, right? There's always going to be, if it's incremental, as was pointed out, that's one thing. But I think we are going to be seeing some major leaps forward in the coming years in terms of, having untethered VR experiences that Alex was already talking about, but also cloud. He mentioned NVIDIA Cloud XR, right? That's going to be a tremendous technology. It takes advantage of 5G, so that's going to be a big change going forward. So, yeah, I think it's inevitable. At some point, you have to make a decision. You make your purchase, and then it's up to you when you feel you have the budget to take that next step if it's worth it to you.
That's cool. So, new question from Tal Friedman, who spoke the other day. What are the costs of running pixel streaming on a mass scale these days, and when do you expect it to become mainstream commodity now that 5G is with us? Andrew and Ken, he said.
So I just
Ken.
had the experience of deploying a pixel streaming experience for 500 people for the World Digitally Built Environment Conference that was held virtually last week. So what we're seeing is there's a range of vendors building on top of the cloud, and the NVIDIA T4 GPU is the kind of that's the platform for all experiences, as far as I can tell out there. That's the only thing available really that supports what we're trying to do. And so cost for that, you'll if you look on Google's site and AWS, I think they're the only two that I think have the T4. They're roughly 50 cents an hour kind of costs. And you can play with those costs by, doing lots of different things with the provider. But fundamentally, that's a per hour cost. And I think that is reaching the point of being able to be useful for a large range of experiences.
Yeah.
I also highly
agree.
recommend
So,
people check out CoreWeave, which is a service that we did a lot of research and settled on them. We're doing this for the Internet of Playa, which is built in Unreal Engine, and they have a system of lots of different computers with different NVIDIA graphics cards, and it does a really excellent job of scaling to what your experience actually needs. And that, among many other methods they go about, help cut down on costs. So I find that they are the most robust and affordable option that we have found. So that's called CoreWeave.
CoreWeave. Okay, that's good. Okay, so the other thing, this is a question from me, it's like Pixar owns USD. USD is the file format which Omniverse is based on. Pixar, from my understanding, will only add things to the core format that makes sense for its kind of 3D visualization kind of world, as opposed to BIM, where there's a big I in the middle of B and M, which is the important part of why we've gone to 3D modeling in a way. So if anybody wants to add to it, they have to either get Pixar to agree it's a good thing, or build an extension to the USD. So what are the plans there to try and make it a little bit more AEC specific or AEC beneficial?
Well, this is Andrew. So, I mean, I can't really speculate on what Pixar and will do or not do, but I think the latter solution that you described there, Martin, is probably a great workaround to move forward.
But you're working with all the major vendors, I'm guessing. So could you give us an idea of which BIM software companies are you working with in terms of adopting Omniverse?
From the AEC's perspective, the ones that we've spoken about publicly is Autodesk and Epic, Unreal, of course, SketchUp as well, and Rhino.
Okay.
And I can say that there are numerous other AEC-focused software, ISVs that we're closely engaged with to continue to expand the ecosystem.
But I mean, it's a good point that USD is not something that the AEC community can currently easily influence. And that's just a reality based on where it's coming from. And we did evaluate it for AEC purposes, and there are things it's lacking for passing design data around. I mean, for what it's being used for, getting a great sharing and collaborating around a visual image, it's purpose built for that. It works great. Yeah. But if your purpose is different than that, there's some questions about can it be used to do those things too. And I think only, it's going to take some time. It's so new. It's going to take time to figure out. Can it also do these other things?
It's worth pointing out that this first iteration, this early release of Omniverse on the what we call the AEC experience is really aimed for the conceptual design sort of part of the workflow. It's the early part. The things that Ken's alluding to get much more complicated as you move through engineering and so on. But we're kind of let's start at the beginning and continue to develop and evolve it.
You'd be very surprised at the number of architectural firms that are looking at USD as being the answer to their prayers for interoperability between various different systems. IFC gets to a certain point, but people want a proper interoperability standard that is that much more advanced. So kind of IFC meet USD would be a good start.
That's the need, is to merge them, because IFC has the context that's missing from USD. So that's the frustration we see too, because IFC is missing, all sorts of things in terms of appearances. There's nothing really describing the appearances that you want, whereas USD has all of those. So there's still kind of a gap between both of them.
And we've got the answer. The answer is USD IFC. So a new style format.
Sounds like a new sports league.
It's too much. Now that Unreal Engine supports real-time ray tracing through RTX, how has this changed workflows of design viz artists now that they're shifting away from more traditional viz workflows featuring, like everybody's favorite 3D Studio Max and V-Ray?
Yeah, I see that the offline will be there forever because there's always going to be a reason for pixel perfection. In some agencies or even in some firms, there's some problems that real-time ray tracing can't still easily solve. But I'd say for 90% of what is done, we're already at the good enough stage. So I think we've reached this point, inflection, where we're good enough for the bulk of the work. And the big advantage, of course, is the ability to compress your cycle, to have tighter, faster, more creative, more iterative design loops. So instead of waiting minutes, hours, days, weeks for the results of a rendering, you have it now. So the power of now is transformative to a lot of workflows. And I think that is a big reason we're being pulled in. This is not us pushing. This is people grabbing us and saying, oh, we need you on this project.
Yeah. One other thing that's a great point, Ken, to add is, it feels like that it's only been the last few years, perhaps, that the software has become much easier to use. I think the ISP has done a terrific job in simplifying how the software is being used. To me, it's and talked to architects 5 years ago. Very few of them would have felt that they could have got to grips with some of the some of the rendering software as part of their workflow, because it was just another tool to learn. It was too complicated. You had to be a photography expert to know how the lighting works and all that stuff. That's really changed in the last few years. It's so much easier now. So we're hearing a lot more about architects who are not archviz specialists, right? They're not necessarily architectural designers, but they're able to use that photorealism that Ken's talking about to really inform their work, and they've got that situation now where you've got adjacent monitors. On one you're working with say Revit or something, and on the other you've got your rendering plugin, and it's a really good it's just better workflow. I think that's what we're sort of hearing.
A lot of people who I know got. Oh, go ahead.
I know Alex has to go soon to drop his son off to school. So I just wanted to get a quick question before you went. If an architectural firm is now deciding to start on this journey and is going to invest some time and effort into adopting VR as part of their design process, what would you say would be the ideal start point for them?
Ideal start point is to get a cheap headset, and for some architecture firms, $300 for like an Oculus Quest 2 might actually be too much. You can get used Windows mixed reality sets for $100 that, in theory, can play all the same experiences as Oculus and Vive and all the other standalone headsets. And then, and the other nice thing about Windows mixed reality is it plugs into most Windows computers, even dating back a few years. And then you can use Steam VR and Oculus to again, make it compatible with a lot of different elements. But then really you need someone, whether it's you or someone else in your office, who is just excited to explore with this. I mean, my journey into this started with just seeing the Kickstarter for the Oculus Rift development kit and saying like, oh, that would probably be useful for our office. And then my boss gave me permission to buy it. And then it came in and I realized like, oh, this isn't like a plug and play thing. Like I need to learn to code. I need to learn how real-time engines work. And so then I spent that time to really explore how to make all of those things come together. And there weren't a lot of courses or anything like that. Then nowadays, there's an incredible number of resources. So really all you need is someone who is excited about this, because now there's, Unreal Online Learning. I have a course on there, and Unity has a ton of great courses as well. And YouTube has a ton of incredible creators. So all the knowledge is out there. So much of it is free. And you just gonna kind of dive in and then find people in the community like myself who are happy to share knowledge and talk more about this. And before I go, I do just want to piggyback on the last question really quick, which I just want to mention that the real-time workflow of outputting renders and animations and all that now really is remarkable. And you saw a little bit of it in my talk, but we're doing so much more of that now. It used to be, of course, you're in 3ds Max and you have 10 billion polygons in the file, maybe some proxies, but you're like trying to navigate around and pick certain angles or figure out what a camera path should be. And that could be really slow and cumbersome. And then you spend 2 weeks rendering it. And then you're like, oh, we got to change a bunch of that. And now, even if we're ultimately going to be rendering using something like V-Ray, the fact that we can have a real-time experience, whether we're navigating in the browser or in VR, there becomes this really incredible, I mean, it's basically virtual production, this workflow where you can be with a client or with your other collaborators, and you can be deciding everything from the framing of a camera shot to how a camera moves in real time and changing colors or moving furniture around and just kind of figuring out in the moment. It's like workshopping what's going to be best. And that is such a relief from the old DCC methods of figuring this all out. So I've seen a lot of incredible 3D artists who used to be entirely in programs like 3ds Max, making their way into programs like Unreal Engine and doing incredible work. And the same way that I used to have to try to convince architects that a lot of their skills could still translate into working in VR because it's a spatial medium, I'm seeing a lot of 3D artists realize that their skill sets translate once they get into Unreal Engine, and they can still produce stellar work pretty quickly because they're still using their sense of composition and color and light. They can just do it a lot faster now. So it's a really exciting time to dive into this all. The barrier to entry is very low. And if anyone has any questions, yeah, reach out to me, reach out to Ken, reach out to Andrew. I know we're all always excited to discuss these kinds of workflows and how to innovate. So I'll leave it there.
Thanks, Alex, and go and sort your son out, and I'll speak to you soon. Okay, right. Questions. Okay. So Twinmotion Presenter Cloud sounds very interesting. How do you pay for that? Per project, per minute? How's it? What's the deal?
I don't think we know that. The beta is going to be free, which is just kicking off. I think next week. It's in alpha right now. Obviously, it has to fit what people's budgets. I think you've seen Epic be very affordable. I think that's our story. We're more about trying to help solve problems than we are trying to optimize every nickel and dime. And I think we have Fortnite in our corner, so that does give us some advantages. So I think you'll be surprised. I hope with what it does wind up costing.
Thank you, gamers, for subsidizing Unreal's efforts.
Yeah, and I just kind of to add on to that, I've got to say thank you to gamers, from the NVIDIA perspective, for actually helping us build a nice R&D budget over the decades, right? I mean, it's fascinating for me to think that, all of those gamers who've been kind enough to purchase our GPUs have allowed us to invest billions of dollars in R&D, which have enabled us to really, develop some incredible, absolutely extraordinary technologies. Thanks, gamers.
Very true. Yeah. Thanks. So, Andrew, for early adopters, how many people have you typically got collaborating in Omniverse currently, and what's the maximum number based on GPUs?
Yeah, so I think the question is about maybe how many people simultaneously all working in Omniverse on the platform at the same time? Yeah. Sounds like I don't think we've reached the limit of that yet. We obviously, as I mentioned in the presentation, this was a tool that it's an internal tool. We developed this for internal use so that we could create virtual worlds to simulate autonomous vehicle scenarios and robotics and all that sort of thing. It's sort of that was the path that we were going down. And as we continue to develop it, I think I can safely say we've had over 100 people concurrently using, collaborating on a platform with all sorts of different software. So, and that, was not, certainly wasn't the limit. So I don't think we know the limit yet, but hundreds.
So if I was to use Omniverse, do I need to have an NVIDIA GPU on my machine to process stuff before it goes up, or is it agnostic?
Yep, no, you don't. You don't need a GPU, to connect into to Omniverse. So anybody with any sort of a lightweight client, a tablet or something, can connect to view. Connect into Omniverse to view what's happening. The part where the GPU comes is very useful is when you want to come up with the highest fidelity rendering. So there's a module called RTX Render in there that if you've got an RTX, an NVIDIA RTX GPU, you'll be able to take full advantage of that, real-time ray tracing, full path tracing, so that you've got the very highest quality, highest fidelity, physically based rendering that you can achieve.
A question here for Ken is, I think somebody probably wasn't paying attention. Well, once you've taken a project from Twinmotion to Unreal Engine, can you go back again?
Not yet. I think in our larger vision is that we're going to tackle that problem. But yeah, that's our hope, is that we can solve the technical issues with doing that.
And with Twinmotion Presenter Cloud, presumably you need to be close to the data center to get a good real-time experience. Where are your data centers in the UK, US?
We automatically find the right instance based on where the user is. So we already have that all figured out. So if you're in China, well, China is a bad example. If you're in Singapore, you'll get the instance closest to you'll be interacting with.
So going back to Andrew, will there be a cloud service for Omniverse where rendering is done in the cloud as well? And will this extend to VR, i.e. Cloud XR?
Yeah, I don't know the answer to that right now. I mean, there's plenty of rendering capability in the cloud today. You mentioned Cloud XR, Martin, or the question is about Cloud XR. This is a really exciting new technology. We launched it, I think, maybe a year and a half ago. We have our first SDK out there that's enabling this. And what's really exciting about this is that it's going to enable streaming from a workstation or from a data center or from the cloud to an untethered VR headset. So this is going to be especially when 5G becomes a bit more ubiquitous, I suppose. Eventually we'll get there. It's still being rolled out, of course. But you can imagine the kind of use cases that become possible when you're on a construction site, for example, or clients' offices or whatever. From an architectural point of view, the ability to do AR and VR, XR, obviously, from any location like that is going to be a tremendous boost.
So someone's asked a question here about point clouds, and I'm quite interested in how the GPU world also is approaching analysis and use of points as opposed to surfaces and triangles. But someone said it may be over the top, but what's the development of turning point clouds into BIM? I'm thinking simple construction elements: walls, doors, slabs, columns, openings. In VR, these entities could carry data like regular BIM elements. So,
yeah, so there's two pieces to that. One is the meshing part of it, in which there are many solutions out there for meshing. And I pointed out there's a company called Cintoo, CINTOO, their .com. They have an online cloud system for processing point clouds into meshes and working with BIM data. And they also have a real-time stream that goes into Unreal Engine. So you can connect to their cloud offering and get streamed the meshed data that you uploaded into the point clouds that you uploaded into their system. So that's a cool thing to check out. But then there is kind of the identification of the objects in the point cloud, and there are a bunch of AI techniques. I'm sure they're running on NVIDIA hardware, of course, to analyze the structure and try to derive whether or not what part of the building it is. So there are efforts to do that. I'm not aware of a tool that does that perfectly. I think that is a work in progress.
When NVIDIA was constructing our Endeavor building, our headquarters in Santa Clara, the first part of our new headquarters, we were using photogrammetry, drone captured photogrammetry, as well as LiDAR to create point clouds of the building as it was being constructed. It was sort of one of those comparisons of as built against schedule and that sort of thing. And so that was 2017, I think I mentioned, right? So 2016, 2017 was all happening. So that's a few years back, and there's been progress since then. But the one thing I remember that was quite striking was the size of the point clouds. They're so gigantic that you need a GPU, well, obviously a professional GPU with a huge VRAM. So as perhaps many of you know, that we do have a GPU called the RTX A6000, which we just announced recently, which has 48 gigabytes of GPU memory. So I mean, that's the kind of behemoth GPU that you require for some of these gigantic point clouds.
There are companies like Corrivate, for instance, who are offering, well, they've developed a service which is on the cloud. So 5G comes along. That's good. You can upload your large point clouds to the cloud. The cloud automatically, their software will automatically register all the point clouds, and that's all processed and delivered back to you. So there's this kind of, it's almost there. The one issue is this kind of just getting your data to the cloud to be processed before you get it. And it was quite interesting where I really like this one little bit where instead of actually sending you the point cloud, which again is going to be a massive, they just send you the recipe of connecting and stitching together. So you can, once it's worked out the recipe of stitching it together, it can send the delta back to your computer, which can then stitch them together properly without having to download a huge file. But
the entire thing.
Yeah, I think there's a lot of clever stuff going on in point clouds. And in some ways, it's dumb data, that's the negative, and on the other side, it's huge. So that's the two downsides. But the kind of AI that you can add or interpret from point clouds is just growing and growing. Where in some ways, it's almost like the perfect raster data to store everything in. You can extract the intelligence, and then later add it back in again because the AI just runs over it, recognizing that's a pipe, that's a wall, that's a window, that's a door. So there's a whole load of possibilities with relatively dumb data, but it's just the size that is the issue. Got one last question, which is, does Twin Motion Presenter Cloud have RTX real-time ray tracing capability?
Not yet.
That's coming.
I'm not going to be talking about the long future here, so I'll just talk about the things near term.
I'm sure Andrew has something to say about that.
So I think I heard Andrew. So maybe this is fortuitous, but someone actually logged me off there for a second, so I missed the question.
The question was, does Twin Motion Presenter Cloud have an RTX real-time ray tracing capability?
Yeah, okay. So, I'll quote Ken on that one, I think.
Right, so that's all the questions I've got. I'd like to thank Andrew and Ken and Alex and hopefully his son for hanging in there and answering all my questions, and also submitting their talks for Next Build Virtual. Tomorrow is the finale. We've got the Autodesk Letters group, and that we have about an hour and 20 minutes of just conversation with them about all sorts of cool stuff, their hopes and dreams for the future for architectural technology in many different aspects. And then we have a Q&A with them afterwards. So I'd like to thank Andrew and Ken who are here again, and we'll see you tomorrow. Thank you very much.
Thank you. Thank you, everyone.
Cheers.